I will talk about service engineering analysis for hybrid computing system of IoT, big data, and cloud. The subject that we have been investigating over the last few years, and I believe that this will be going to be more and more important in the next couple of years, at least 5 years in the research program. I don't have a very long-term perspective. So you might wonder what does mean hybrid computing system and why service engineering analysis techniques are crucial for this. So you look at the screen, then there are some few representative application and system. So I think in order to understand hybrid computing system, it's really better to look at what kind of software system that we are researching and developing today. So example like real-time smoke analysis, something probably very familiar in Finland. Traffic monitoring and management in my home country. And enterprise services and digital transformation, for example. So if you look, for example, in real-time smoke analysis, there's a lot of things happen inside it. So we need to monitor, for example, the activity of the players and the health of the players, and we have to make a decision at runtime, right? So this is essentially a social, cyber-physical system, but with a lot of machine learning and data techniques, data analytics techniques, right? For traffic monitoring and management, you need to handle how to collect data from various sources, right? How to make a decision, especially how to deal with this kind of system when you have the infrastructure is very fragmented, for example, like in Vietnam or India. Extremely difficult. If you look at enterprise services, for example, how do you support companies, right, to do digital transformation, but not serving for hundreds of customers, but maybe hundreds of thousands of customers. This is extremely difficult for us. And this is the subject that we are very interested for us to do the research, and it's a very challenging to develop and operate such a software system, right? From the picture, it looks simple, but if you dig inside into such a software system, things is really complex, right? You will see there are a lot of elements of Internet of Things, something that Mario already mentioned. There's a lot of things related to big data and machine learning, AI, cloud computing, and humans, right? For example, we use Internet of Things to collect and monitor and collect data. We have big data to move the data from one place to the other place and process the data, a lot of data. We have cloud computing provide unlimited storage and computing capability for us to run machine learning algorithms, streaming data analytics, big data workflow. And of course, we have humans as a way to improve a lot of automated processes. So the question is, how do we optimize the development and operation of such a software system, which we believe that is really important nowadays. So one way is to think about a new notion, right, and a new way of doing this. So for us, I think that we need really a new notion and a new techniques to deal with this problem, what we frame into what we call hybrid computing system. So a hybrid computing system here, it means that the question, how do we able to build a system where we can glue different capability from different type of system, like Internet of Things, big data, and cloud together, right? And abstract the capability as a service. So by abstracting the capability as a service from different kind of infrastructure and system, we will be able to utilize different capabilities, from constrained to powerful machine. And also from professional humans or crowdsourcing, for example, all together in order to build a very good, very complex software system. And I think that we need this because for solving such a very complex problem, we cannot rely on a single capability. So IoT is very powerful, but it's not enough. AI is very powerful, but it's not enough, right? So the question is, how do we glue them together? And working on these topics, we believe that we can simplify the life of the developer a lot, right? If we are able to provide them with high-level abstraction, like hybrid computing system with hybrid service unit, the developer would be, not only we hide a lot of low-level details and enable dynamic software system, but we also release the developer from a lot of time-consuming efforts and so on. But we are not going to build hybrid computing system in a very small scale. What we are interested in is to have a very large-scale hybrid computing system where we can serve a lot of customers. And in fact, in many cases, also in my practical work with industry, we aim at serving millions of customers. So it means that our hybrid computing system must be responsive, elastic, and resilient, right? And in order to do that, we need really novel service engineering analytics techniques. So the service engineering analytics technique must work with different application requirements. So some application requirements that you already see before, for example, how to do predictive maintenance in manufacturing industry, or how to really improve the digital transformation of enterprise, right? Can you turn a typical train station or train service into a train service that can serve for a million customers like in China, for example? We also need to deal with different services, system, and infrastructure. Some of these, for example, like how do we deal with multi-cloud data center, right? Or how can we incorporate data as a service? How can we incorporate optimization software? And very hot topic nowadays, for example, blockchain as part of the system, right? But of course, we cannot just talk about application requirements, services, system, and infrastructure. We need to also to work on engineering methodology. A lot of engineering methodology already there, but are they suitable for hybrid computing system or not, right? So what I'm going to talk in the next is some of our contribution and direction. That's something we already done the last few years, but I think there's a lot of long-term perspective in this research direction. So one of the first things that we would like to consider that how can we abstract capability from, for example, Internet of Things, from network function, from cloud data center into services. And then we glue them together into what we call a resource slice. So for the application, for example, what they really need is resource slice, include different capability from different sources. They don't want to deal with a particular thing in IoT, network function, or data center. Because you can have like a millions sensor, you can have 100,000 of containers running in the data center. It's way too complex for the developer, for example. So if we're able to glue them together, right, we can provide what we call a resource ensemble. And resource ensemble is a very interesting concept that we developed. It's not just about a set of resources from different places. But in order to make a resource ensemble available for the application, you need to deal with requirements. You need to deal with metrics. You need to deal with a lot of policy. So it's the way where we can collaborate, for example, with people who work on security, privacy, and adaptation, and so on. Right? Another concept that now we have the way to glue many resources from different places. So we focus on the study of what the elasticity concept. So we only know that the elasticity principle that if we, for example, if we put some pressure, then things will change. If we release, then things will go back into the normal. So now if you have a lot of capability from Internet of Things, right, from human, from big data, from cloud, right, we are able to glue different capabilities. So it means that we have a very flexible way of changing the resource, right, at runtime. But every resource have different kind of quality. So maybe the AI is really good, right? Detect a lot of things, but it's very difficult to detect, for example, whether cats or mouse, for example. And human could plays a very important role. So with different kind of quality and cost, right? So the question is, if we're able to study elasticity, what can we do, right? So in our work, we're able to develop a couple of very interesting concepts. So first of all, we develop a concept of quantitative analysis, and we apply for big data pipeline. The principle that is, when you run a big data pipeline, or maybe machine learning or whatever, you can specify different kind of resource, time, money, what do you want? And based on the trade-off elasticity, we can optimize. So maybe if you pay more money and you don't need time, we can run a very powerful algorithm, right? Take a little bit of time, but produce very good result. If you say tomorrow I have to submit a paper, okay, you pay less, and then run things very fast. Maybe the result is not very interesting, for example. Another application we developed is to apply multidimensional elasticity for software-defined capability in software system software, where we can replace, for example, components, replace process, right? Add and remove things based on the quantities. So something we apply, for example, you monitor the data from the sensor. You know that there's a lot of problem with sensor data. So one of the interesting things that if you want, you can insert a new algorithm to do some kind of, like data summarization, for example, right? To have us to deal with a lot of data. And the other thing that is, if we apply the multidimensional elasticity, we can actually also able to provide resource ensemble based on application-specific context on demand. So that's three things, for example, some of the things that we developed based on the concept of multidimensional elasticity. Another thing that is now if we glue IoT, big data, cloud together, right? Then we have a big problem. That's there's so many uncertainty and incidents happen into a very big system, right? So for example, if you include a people inside the process, and that people, for example, somehow just have not working very well, it means everything will be delayed, right? So the thing that is a lot of uncertainty might happen, a lot of incident might happen. And the question is, how can we deal with that? So this figure shows you very simple example where we monitor base station of a telco, right? So we have, for example, a lot of alarm at the beginning, but then there's someone, there's no alarm. So what has been happened, right? Is our system run perfectly, so all our engineer now fit the problem so there's no alarm? Or actually the software system has some problem? It's not easy to answer. Because behind this one, you see that 1,000 sensors, a lot of server, a lot of data pipeline. So the key thing here that we need to really understand the underlying system, right? And then try to trace and figure out where is the uncertainty, where is the incident. So for this, we developed what we call a W3S, Deep Analysis Model. And I think this will become very important. The question is, how can we answer the question, what, when, where, and how the uncertainty and the incident happen in the big system? Right? Remember that we have Internet of Things, we have AI, we have cloud computing. And it has to be integrated with a software engineering process. Right? And I think this is really crucial point for us in order to really implement the right big data pipelines or even the machine learning pipeline. Without this, I think this will be a lot of issue. That, and the last point I want to mention is about the engineering principle. So we have developed a couple of, we applied a lot of methodology for hybrid computing system, but we figure out that, okay, they are not really for hybrid computing system. So how do we improve engineering principle to make existing principle, existing methodology suitable for hybrid computing system? So one of the things that we need to focus more on end-to-end engineering and optimization. Right? And I think our previous talk also mentioned a little bit about this. So the thing that is you have IoT, you have cloud, you have big data. If something wrong in the IoT, maybe all the AI analytics in the end, it makes no sense. So if you don't consider this end-to-end, then there will be big problem. Another thing that to deliver the good results for the user and optimize the resource, you need to look at elasticity coherence. So you have different elements in the system with different degrees of elasticity. So if you activate, for example, all the sensors in this room, right, then you don't coordinate the activation of machine to analyze the data in this room. Maybe your system will be collapsed. So how do you coordinate the elasticity across the system? And the last point, I think very important, that working in hybrid computing system, very large system, we never start from greenfield. We always start with some production environment which already there, right? So if we have a city with a lot of infrastructure and we want to make the traffic management to become more intelligent, it's not that we start from zero. So the production environment already there. So how do we really combine our development environment, our testing environment with the production environment? And that's why we push a lot of effort on investigate what I call engineering symbiosis. And we apply engineering symbiosis for a large-scale system where we need to combine our development environment, our research environment with the production environment. So the four main points I mentioned, I think it's just a starting point. We have carried out this kind of research over the last, I would say, like 5 years, but still, a lot of things we need, a lot of things I think that we need to do in the future. And I think that would be enough for the next, let's say, 5 years of research with a lot of questions that we can try to answer. So one of the first focus would be how do we characterize, right, hybrid computing system? So give you a very simple example. If you have a machine learning algorithm to analyze, for example, the bones of your body, and then the doctor will take some examination, right, in order to make a conclusion. If we look from the characterization, what can be used to represent the system in terms of end-to-end? A very difficult question, right? And then how can we do the monitoring, measurement, and benchmarking? So when should I replace the doctor by the AI? Because the doctor may be very slow, right? But he probably give a very good indicator of what could be a problem of the pattern, for example. And then we need to focus a lot on analysis model, techniques, and algorithm in order to bring up with the way to optimize hybrid computing system. And I think that we can also eventually provide ensemble as a service. So I would not want to say, Google, give me 100 virtual machines, right? And the other, give me 10,000 data stream from the sensor. I would like to think about the capability, right? Capability, the data capability, analytics capability, computation capability, and then I would get this. And then things can be changed at runtime based on what I need. So thank you very much for your attention. So I hope that having this new notion of hybrid computing system with a lot of things related to IoT, big data, cloud, something like this, we are able to collaborate with many groups in aalto. And I believe that that would be enough for me, at least for my team, in the next 5 years. Please visit our website and check what we have been done so far. Thank you.